2 roots of u plus c. But what's u? 2 minus x. Okay, is that all right? So now I'm going to come back here. I'm going to write the limit again. Limit t approaches 2 from the left. The antiderivative, negative 2 root 2 minus x. My evaluation bar is going to go from 0 to t. I always say 0 to t, and I've heard other people say like t to 0. Do you all know why I say 0 to t instead of t to 0?
You're starting from the bottom.
Yeah, I do. Why go bottom to top instead of top to bottom? Why do I do that? Because if you look at, I mean, the interval is from 0 to t, right? From left to right on the number line. So that's the way I like to read it. This is the way it would appear on the number line. Know what I'm saying? Okay. All right. Now what? Evaluate it, right? Write the limit again. T goes to 2 from the left, bracket, parenthesis, parenthesis, right? Give myself a little more room this time. Plug in which one first?
0.
T first, right? T goes first. T goes first. So negative 2 square root 2 minus t. And then how about 0? Just plug 0 in for x, you just get negative 2 root 2, right? Negative 2 root 2. And now we get to let t go to 2 from the left. So has no, there's no impact by t here, right? T doesn't appear here. So this is just going to be this. Here, though, when I replace that with 2, right? 2 minus 2 is 0, right? It's approaching 0. And if that's 0, this whole thing is 0. Now, why do you think it's important that we're approaching from the left? I mean, that actually is pretty important here.
Because we'll never actually hit 2. It'll be like 1.999.
Yeah, so we're going to be plugging in numbers that are like 1.999, something like that. And if you look at 1.999, that if you take 2 and subtract that, you're going to get a little tiny positive number there, right? Mm-hmm. And you can take the square root of a positive number. However, had this been coming in from the right side, and we were on the other side here, then the number you'd be plugging in would be like 2.0001. And if I do 2 minus that, that's going to be a negative number. And then you have a root of a negative and imaginary. And so it's actually critical that we're approaching 2 from the left, or else this limit starts to have some issues. Make sense? All right. But at the end of the day, it's 0. This goes to 0. All right. So I've applied the limit, so I don't need to write it anymore. Then I have what? Minus minus is plus, so plus 2 root 2. And that's finite, right? That's a number. 2 root 2. This converges. So that the area below that graph on that interval is finite. Questions? Speaking of 1.99, I'll give you some, we have a little bit of time. My class today, we ended about 15, 20 minutes early, so I have a little bit of time. I just will ask you real quick. If you look at the interval 0, 1, okay. What's the number right next to 1? So here's 1, right? We all know 1 is 1. What's the number right next to 1? 0.999, infinite series of 0.99? Seem reasonable?
Also 0.5 or 0.4 or 0.1.
So one question here is 0.99, but you're saying repeating, right? Because you can't, if you stop, then there's going to be one. .999? Yes? I mean, does that seem fair, logical, maybe? Yeah? All right. We'll see. Let's see. Let's see if you believe this or not. Just before we do it, if I take the number 1.57 and I multiply that by 10, what do you get? 15.7. Another way you could think of that is all I really did was what? Move the decimal point one place. So if you multiply by 10, your decimal moves to the right once. Yeah? Okay, here we go. See if I can convince you of this. Ready? You just let me know if you have any problems with what I say right now. I'm going to let u be equal to 0.999 forever. All right? Happy? Okay. Now, then 10u should be what? 9.99. And I have an infinite number of 9, so I could just write this again, right? Agree with that? All right. Now, right here, I'm going to write down two things. First of all, what's 10u take away u? Just algebraically, if I have 10 u's and I take away 1 u, how many u's will I have? 9 u's. Everyone agree with that? Still good? So, but what was 10u? According to us, 10u was 9.999 forever, right? And what was u for us? So if I subtract from that 0.999 forever, what happens to that 0.999 stuff? Isn't this like everything from the decimal point this way is the same as everything from the decimal point this way? So if I subtract, shouldn't that decimal point stuff go away? And just leave me with 9, right? 9. So what we're saying is 10u minus u algebraically is 9u. And in this particular case, the 10u and the u were this, and that subtracts to be 9. So these should be equal, which means u is what? 1. Divide both sides by 9. So 0.99 forever is 1. That's not a trick. That's the truth. So not 0.999 is not the number right next to 1. 0.999 forever is 1. You've just never seen it written that way. That's weird, right? And then, so to answer the question, what is the number right next to 1? There is no number right next to 1. Okay? It's impossible to find the number right next to 1. Because let's just say that you found it, okay? Everyone? Let's just say you found it. And let's just call it x. Right? And you're telling me that that's the number right next to 1. Then here's what I'm going to do. I'm going to take x, I'm going to add 1, I'm going to divide by 2. So I'm going to take the x that you found plus 1, which is the endpoint, and divide by 2. This is the average of the two numbers. And the average of the two numbers will be between them. Let me see if I can convince you with another example, because that doesn't make a whole lot of sense when I say it. Let's say I say 3 and 5. What's the number right between the two? 4. But here's how I could get 4. 3 plus 5, divide by 2. Take their average. You can always find a number between two numbers by taking their average. So as soon as you think you found x, that's the one right next to 1, I can always average it with 1 and find another one. So then you say, well, that's the one, and then I just do it again. There is an infinite number of numbers right next to 1. You cannot nail 1 down. That's what makes our number system so crazy, is that it's so dense. There's just so much in there. As soon as you think you've, like, if you try and walk from 0 to 1, it's not like walking across lily pads of numbers. It's not the way it works. As soon as you walk to a number, you look back and you realize you missed an infinite number of lily pads. So it's like this crazy infinity that you can't even count. Okay, I'm way off topic. Sorry, I just saw 0.99 earlier and I just started thinking about that. All right, how about this one? Stop. Any ideas?
4 would be replaced with T.
Replace what?
T with 4.
T with 4, where are you getting that from?
Because if you put 4, you get 1 over 0.
Okay, so did you factor or you just kind of inspected?
Actually,
Okay. If we factor the denominator, because we realize the denominator is a polynomial and it factors out pretty easily, there's actually 2 places where we have discontinuities, right? Where are they? 0 and 4, right? 2 places that this function would have trouble. Now, for us, we're looking on the interval 1 to 4, and the only thing that really causes a problem there is the 4. So the 0 here doesn't matter. That part is not going to be impacted by this integral because of the interval of integration. We're going to approach 4 from the left. So let's just go right to it. This is going to be a limit. T is going to approach 4 from the left side, so a little negative sign there. And then I'm going integral. I'm replacing the 4, right? So it's going to go 1 to T. And then 1 over, hey, I may as well leave that factored. Why should I leave that factored? So I've got to integrate that now, right? And what am I going to do that? Partial fractions, right? I'm going to have to do partial fractions to integrate this. So I better do that over here. You understand what I'm saying? Like, we got to do some work on that. So partial fractions. I think I can squeeze it right into this little area here. Partial fractions. At the end of the day, I need to turn 1 over x times x minus 4 into something, right? What's this going to be over here? A over x plus b over x minus 4, and that's because I have 2 distinct linear factors, so I do a constant on top of each linear factor. I now multiply both sides by the LCD, since you all spent, I'm sure, most of the weekend doing this. You're all comfortable with this now? How would you do this? Like, you're taking the test. You got that. What would you do? Are you going to do a system and do RREF, or are you going to try the shortcut?
You didn't have to do it. You could just see you could just see the A's before. Negative.
I mean, yeah, so that's up to you. I don't care what you do. You just got to get it right. So I'm going to do shortcut. I'm going to first let x be 0. That'll kill off this term. So if x is 0, what equation comes out if x is 0? You get 1 equals, right? X is 0, so negative 4 times a, you get negative 4a. And that means a is negative 1/4. Now let's kill off the a. So we're going to let x be what? Let x be 4. If x is 4, this equation becomes 1 equals, that's gone, 4b, which means b is a 4th. All right. So let me rewrite this. This becomes a, which is 1/4, or negative 1/4, over x, plus b, which is 1/4 over x minus 4. So I found my a and my b. And that means when I go to integrate this, right, it should be pretty straightforward because I can bring the constants out, and then each one of those will be a natural log. Is that fair? So I'm going to do that. I'm going to just go ahead and do that right now. I'm going to say limit t goes to 4 from the left, and now the antiderivative. The antiderivative, well, you know what? I don't want to try too much at one time here. Let me just continue with this up here. If I integrate this, integrate negative 1/4 over x plus 1/4 over x minus 4 dx, then that becomes negative 1/4 ln absolute value of x plus 1/4 ln absolute value of x minus 4 plus c, right? So that's the thing I'm going to plug in over there. And then I'm going to put the bar, and then I'm going to put a 1 and a t, and then I'll do a limit. Yeah, I could pull 1/4 out. Yeah, you want me to move that to the front? Sure, I don't mind. But let me do you one better. How about this? How about 1/4 natural log x minus 4 over x? I did it, so I want to see if you follow this. What I did is I just rearranged these like that. Okay, so I put this one minus this one. So imagine, switch the order of these. It would be 1/4 natural log x minus 4 minus 1/4 natural log x, right? Like that. And then pull the 1/4 out. So the 1/4 is gone here, like that. And now if you subtract 2 logs, it's division. So there you go. So sure, we can do that. I like that. That's the cleanest version of it. So 1/4 natural log of x minus 4 over x. Then my evaluation bar here, I'm going to put 1, 2, 7. Questions? Okay. Now we get to evaluate. So I'm going to have a set of a limit. Don't forget the limit. T is going to go to 4. We're approaching 4 from the left. Bracket, parenthesis, minus, new parenthesis, bracket. All right, T goes first. So 1/4 natural log T minus 4 over T. And then 1 goes next. 1 goes in for x. So 1 goes into here. 1 minus 4 is -3, right? Over 1, so that's -3, but it's absolute value. So natural log of 3. So we have 1/4 natural log 3. Pardon?
How come the absolute value falls off?
Because the absolute value of 3 is 3, so I don't need it anymore. It's not a variable anymore, so it's under control. Like the 3 is not going to change to negative. Yeah, so let's see. Now let's take this limit. As t goes to 4, right, from the left, plug in right here. What's that going to give you? 4 minus 4?
0.
Is 0 over 4, right? Because we're plugging in t is 4. So that piece right there, this whole thing right here, and I'll forget the 1/4 for right now, just this, is behaving like this, natural log absolute value of 0. Now, I'm not saying it is that because it's a limit, but it's approaching that. So what is the natural log of 0? Like, what the heck does that mean? Natural log of 0 is undefined, right? But this is a limit. So this is really saying, what is the natural log function doing as its argument, right? Here's the argument of the function. The argument is approaching 0. What does natural log do as its argument approaches 0? It goes to -infinity. So you have to go back to the graph of natural log, right? Natural log looks like this. And as you go towards 0, right, as you head your x values or your argument, your inputs go towards 0, your function dives down towards -infinity. So that thing is approaching -infinity.
Did you know that also if like the top part was negative and the bottom part was negative, like you said before, if they match like the finite number or no? Not the same.
No, that only worked if we had